So that's why I said it was a good problem, because they don't really it's misleading at first. It can actually send your wheels spinning for a little bit. And it forces you to learn those definitions really well. So you're going back, if you say, okay, I think this might be a cumulative distribution function. Well, the definition is on the previous page, and it's kind of like compact. It just says if it's a probability y less than or equal to y, that's the definition of a cumulative distribution function. So can I take those properties that I gave you and prove that it actually has that probability? Probability density functions have also some properties. And if you go look at the next page in your book, they have a definition of a probability density function. And in that definition, they talk about the integral being another representation of the distribution function. Those are for continuous random variables. So then your mind starts spinning a little bit more and says, can I make something that's continuous and satisfy those criteria in the theorem, but not have the property that when I integrate it, it gives me the integral 1. Right? The area under the curve is not 1. So some of you are drawing pictures. That's where I started too. So Amy said, I don't have my mathematics. I don't either. In fact, I'm probably not going to renew the license because I can't find the password. But if you look here, I just drew something. I want at negative infinity, I want it to have limit 0. At positive infinity, I want it to have limit 1. And I can do whatever in the middle I want. So I thought I'll just make it so that the area in there is bigger than 1. And then I'm done. So I made it as easy as possible. And I can even give you that function. It's monotone increasing, limits 1, limit towards negative infinity is 0, but it doesn't satisfy the fact that the derivative where it came from, the area under the curve, doesn't end up being 1. So it cannot be a cumulative distribution function, right? So I think Nate actually had an example where you just took, oh, I remember that arctan, it had that leveling off. I'll just adjust the arctan so it levels off and it won't have an integral underneath it be 1. Aiden was thinking a little bit more along the lines of what I had up here, where, can I just draw something and get it to mess up? He actually came up with an exponential. So an exponential in one direction and piecewise defined, but it's continuous. So that's the kind of line of thinking that you're going to have to do, like exploring through all of these problems are kind of the same. You have to kind of explore through the definitions. And that's why it's good to have them in front of you, so you're not flipping around. You might miss something in the book, but if I have it sitting right in front of you, then you'll see it. Any questions? Right, let me quickly run through the last problem I gave you. Can I have you close laptops? So I think this, I gave you a statement to prove at the end. I just wanted to go over it a little bit, you have a couple things about density functions, specific ones, and proving them. Scratch work. This is kind of one of my physics friends said this is show me problems. You have the definitions and you just lay it out and run through the formulas. So it's a show me problem. The median equals the mean. The reason I wanted to show you this problem is the median, if you're in real analysis, this is actually an infimum, but I told you to think of it as a minimum. The definition in your book is like really hard to read. And so I wanted you to be able to read that and know what it is. It's the minimum of the y such that this is true. So the p that they have, it really annoyed me they're using p. We're using p for probabilities, we're using p's for everything. So that annoyed me. So what does that little p mean? It's actually half would be the median. It's the percentiles. That's what that is. So I want median would be the 50th percentile, it'd be 1/2. 30th percentile would be 0.3. So that you just change that number to whatever percentile you want. And I know how to calculate this. And the y that you have is what you're looking for because the cumulative distribution functions are monotone increasing. Right? So if you want the minimum value, you just have to solve for that upper bound. And so I gave you a problem like that on the homework to actually dig through the definition. This one digs through the definition with numerical answers. You like it? It's got numbers in it. So here I did the work. The work's not that important. Well, maybe it is, right? I worry when I hear Colonel Clark saying that because he's probably right. It is probably important. So I go through the calculations. and I show that the median is equal to the mean. It's just integration by that time. Good? All right, so the homework should keep you out of trouble this weekend.